Okay, everyone, this is my week 7 homework for my CSE programming with functions class. I've technically already gone through all this because I didn't really care to go through and explain everything what I'm going to be doing because I'm not happy with just reading it. I want to experiment with everything and see exactly how it works. Um, and I learned last week about debugging and running through step by step. And I'm going to use that to see what all happens in here. We're going over testing function, or we're going over lists, how lists interact with functions. And I'm just going to see what each step does. So run and debug. Oh yes, to use the debugger, you may have noticed this. First thing, you insert a breakpoint with the way my VS Code is set up. I can just click onto the left hand side here. It inserts the breakpoint. I then click this little play button with the little bug on it, and it gets this. And then I want to run and debug with the currently active file. What I found as I've done this in the past, I only have to tell it the first time after opening it. So if I go to run this again, it will just assume that's what I'm planning. So you've got a few different options you can step into, step over. And while the step over can do things like step over print statements because you don't see a whole lot in there, I like to use the step into just because. And that's really my whole reasoning behind it. In fact, I think I might move my breakpoint. So I just right clicked. I'm going to put it back here. This little guy here checks to see if the name of the file and the name of the function initiating this is main. I don't understand it completely, but basically this allows for me to export this into other code and allows for more reusability, which is a good thing. And so now that I've moved it one step back, this will be when if I were to launch the program, launch the program, this would actually be the first thing actually launched. It won't really do anything. It just checks to see, is the thing that's initiating this main, which is right here, or is it something else? And if it's something else, it doesn't initiate main. If it is, then it launches. And this will show you what I was talking about. It didn't ask me this time, hey, what are you planning on doing? If I were to close this down and reopen it back up, it would. But what I'm looking through is what happens each step of the way up in here. Don't need this, don't need that. And now nothing changes there, not surprising. This just is showing there. Let me take a look here. Main function, special variables. Okay, so nothing really there. And there we go. Okay, return main none. Oops. I think I accidentally, oh, I hit back. Oops, my bad. And apparently I can just hit F11 and go that way. So, and it doesn't show up here. What I think I've gathered is from testing this is that this is showing where it's at before it initializes. And now our list is here, which is this guy here. And that has all of our colors in there. And then if I go one more, yep, it then counts the length of the list, which is 5, which is accurate. And then from there, that will end up grabbing the green. And that sets colors 3 equal to purple. And then from there, our list changes from where it started at the yellow, red, green, yellow, blue to removing the second yellow and going and putting it there. And okay. Now, so nothing too exciting there, but I like to be able to see it in example 2, which is the next one I'm going into. Now, let's step out of my debugger. And let's save and remove breakpoint and put the breakpoint in here. And now running debug again. Let's go ahead and make this a little bit bigger because that's where I'm focusing at right now. And that's just creating an empty list. That this line will make it so velvet will appear right here once we skip past it. There we go. And this line will do the same. Denim will show up there and gingham will show up when we activate it. Okay. Yes, that is what's so the debugger mode is still kind of new to me. I'm still figuring this out. What it looks like is this stops it prior to each line actually activating. So the line that's highlighted, it shows what line is going to be activating next. And so this is going to, so the append function, for those who are newer to programming like I am, appends the item in question to the end of the list. The insert function is going to insert chiffon as item 0. And so velvet will go from index of 0 to an index of 1. All of these will be moved down. and we'll see it happen right here. And there we go. That put it right over there. And then this would print fabric down to the terminal. And this is looking if Gingham, this is just a simple if statement. If it's in the list, then it's going to print Gingham's in the list. We likely won't see anything up here in the terminal, which is just fine because that no values are changing. And it won't, this wouldn't do anything because if we were running this down here, because Gingham is still in the list, and this we'll get the index for Velvet, which as we see right here is index of 0 because computers start count, or index of 1 because computers start counting at 0. And yep, that put a 1 there. And this will change the Velvet to, as it suggests here, we'll see the Velvet gone and Taffeta put in there. And that puts that in there. And from there, the pop function, as suggested in here, is just going to remove the last item on the list, which would be Gingham. So our list would go from 4 long to 5, or 4 to 3. And then this will remove Denim, which will take it down to 2. And then when we skip here, N should show up here with a value of 2. And then that would print out the whole list, and we can kind of see all that down in here. Okay. And then we get back down to the start of the program. Okay, that's cool. And now let's grab example 3. And I know it doesn't do anything, but I still like it at the first callable, first actionable line, because I just like it. And then program initiates. And that's where we see those. And then down in the terminal, which I should probably increase the size of, if it's going to let me. There we go. Oh, wait, wrong program. I've got a couple of VS codes open. There we go. And go. And that color red. Why is color equal to red? Oh, okay. I see here. So color is red because it's the first iteration of the loop. And once we skip past here, it will go and print out everything to the next step. Oh, we get to see the color change. Cool. Get to see it loop through each time. That is neat. I've not seen it do that. And now it changes to orange. And then it should go to yellow once we get down here. And then it should go to green. And green will get printed out now. And then it'll go to blue. And then blue will get printed out down here. That is kind of neat. So if you are ever curious to see what ends up happening as it runs, I know this is kind of simple, but I find this really fascinating. I like to see how the program runs. I'd just like to dive in and know as much as I can, because that's just me. Curiosity is fun. I love exploring my curiosity. I love seeing how things work. I love playing with them. And oops, I missed main. And I love just watching the ins and outs. There's rarely a time when I don't want to dive in deeper. And again, I'm just using the shortcut for this, which is F11. All you need to do to find the shortcut is to just hover over, and excuse my burp. Okay. For I in range 10. So this should, if this works the same way the last one did, this should walk me through step by step to get from 0 to 10. Yep, I is now 0, right up in here. And it's now 1. And now we should escape the loop. We should get a blank space down here. This will start at 5, and I think it'll move to 10 or 9. I don't know which one. We'll find out. And 5, 6. Oh, it just moved to 9. Okay, so I'll have to remember that. This, for when you're doing a range like this, and put in the optional second one, because obviously same syntax here, for I in range, whatever, it gives us this is the starting point. This, we skipped the starting point, and it just counted up 10 increments. And if you skip the starting point, then this tells you the ending. If you don't skip the starting point, then this tells you where to stop before. So it will stop at 9. If you wanted 10, I'd have to put this to 11. And I might change. I'm going to check that. So that, just to play, because playing is fun. And let's jump past here. And now we should get to 10. And then it skips past. And okay, so the third argument gives how you increment it up. And so this will go and start at 0, count up to technically 8, because it wouldn't do 9. And then it would stop. And that goes to 2. And then 4. And then 8. And again, it stops. And so you can even do negatives. So this will count from 100 to 70, because again, it stops before the number. Even when counting down, that's good to know. And it'll count by 3s. And starts off with 100, 97. That's cool. And it skips through there. Let us go to my next example. And insert the new breakpoint, run in debug. And this should get colors up there for color in colors, print color, and so it should jump through red, orange, yellow, and red, orange, yellow. So this is just showing it works the same way for, it handles numbers and strings the same way. And then, oh, this will be interesting. Range. So this is printing the index then. Oh no. Okay. So this pulls the index. This uses the index sets to find the specific color and then prints the color from here. And red shows up. Huh. So these two things do the exact same. This one is just cleaner looking code. This one is a little clearer. You see more of the steps behind the scenes because the computer is going to do the same thing here as what we're seeing here. This just lets us see it. I think in a real programming environment, we'd want to do this unless you have someone who wants to see every step of the way. Okay. And then let's go to example 6, remove breakpoint, because I'll be moving it here in a moment, or at least most likely. And for I in range 10, input a number. If number equals 0. Okay, so up to 10 numbers. And then it adds them up and then prints the sum once you're done. That'll be fun to see. And Oops, wait a minute. Control C, because I want to do, nope, run. Come on. Okay. And now sum has now been set to 0. Now it wants us to run through this, and it should ask us to enter the number when I get to here. And okay, so I has been formally set to 0. And now I want the number, so 1, 5, whatever. And this will check is number equals 0. And then that'll break out of the loop. It's not, so it just skipped it. And now when I go past here, it'll jump back up to here and increment I to 1. Oh, sorry. It now has added the sum up. Forgot that step. And now I has been incremented to 1. Number is still equal to here because we haven't given it a second number. And now we've given it a second number. And now it's going to add those back in. And increments U. Going to and this is a float, so oops. You might want to make sure I'm actually looking in the right area. Let's speed past this because I've already gotten the gist. And let's break out. So now number equals 0, which means it goes into here. Loop gets skipped, and then it would print out the sum, which is what we saw up there. Okay. Now let's go take a look at this next one. And this is why I should remove the breakpoint before I paste in the next code. And stop my debugger and start it up now. And list 1, list 2. There. Okay. And wait a minute. So if index compare list if index equals -1, contents are equal, otherwise differ. Okay, but we didn't get to see what happens there. That's interesting. It just, oh, there we go. Never mind. And I think I hit F10 last time because this actually shows me. And okay. Oh, that's interesting. So why did it skip from there to Careless. So let's take a look here. Why didn't it go into more detail about the two lists? Let's go back in and then I'm going to actually step over. Yes, so let's just analyze this one without the debugger then. Contents of the two lists. If the lists are not equal, return an index of the different. Right. List. So that would return the length of the list. Limit. Okay, so that gives you the minimum length. And then it goes from there. You get the first item repeat until there. Okay, so let's go and change you to see what happens here. To Brown and run and debug. Now, do we get to see something different? Because what this is doing down here is it goes through and each element in the list, starting from 0, it looks like, and then it will keep going through element by element. And okay, so I see. So this goes through, yes, element by element, compare. Do the two equal each other? If so, then it keeps going through the list. If no, then it breaks and goes and stops from there. And if the length, and this stops if they are, if the length of both are equal, the computer verified all the elements are equal. Set to, I don't know if this program is working right, or I'm just not understanding it. We'll find out. And let's see here, compare lists. And this compares the length here. That's the same. And now 5, I is 0. Okay, so all we needed to do to get past was to change one of these to a different, wait a minute, that was already different. So why is it letting us through this time? And you're comparing red. Red to red. That will increment up to 1. Now it's going to go red or orange to orange, increment up to 2. And this will end up not being the same, which should mean, oh, so this is just, okay, so this will break out of the loop after this because the two elements aren't the same. And if the length, so this should set I to -1. Interesting. Returns to. Okay, now we get to the end. So let's see what this thing does if both are exactly the same. Now, run and debug. This sets our list. This is now starting the process of comparing them, gets the length to set the limit. And I equals 0. And now it should go through and confirm that each item is the same, which should get us a -1 returned instead of our 2. And that, if length equals, that should set, yes, okay, and we're good. Now, I want to, don't make the same mistake, although this one won't be. Okay. There we go. And I really should stop the debugger before I go and change the code. Oops. Or put the breakpoint in the wrong thing. Okay. And I just learned something. I always thought you had to delete it because when I first would click it, it would still be there, but I just realized that that it's there because the dot shows up there because the mouse is there. That's good to know. Saves me a click. And let's see. These elements are indexes, each element in the list. Year is indexed to 0, height is indexed to 1, girth is indexed to 2, and fruit amount is indexed to 3. Okay. And apple tree data, year planted, height, girth, fruit amount. Okay, so I think this might have been better if they put it as a dictionary. And apple tree data. Oh, okay. So this is a list of lists containing data about separate trees. You had two planted 2012, one planted 2015, one planted 2016, and then they give you the height, I'm assuming in meters. And then the girth and the fruit amount which is likely. Okay, and there we go. And one tree, so it jumps here, which is for 2. Why did it get tree data 2? So one tree is set to 15. Okay. Okay, I see what I was looking at then. So I again forgot that I always think this is the line that I'm seeing active, but I'm seeing the stuff before. And I was looking to here to see, okay, what is this going to be looking at? And what it almost looked for a moment like it was this, but no, it was actually just showing me the stuff before. And now this will give height index of 1. Okay. So this will then, for height, will end up pulling out this because it's indexed up here. And so that pulls out the 2.3 here, and then we're good to go. And we have this guy. Come on, give me just my numbers. There we go. And then restart my debugger. And this, Okay, so this is a very similar code example, and just the same thing there. Wonder why it goes back up there before. Well, okay. Does not like backing up like that. That's good to know. Oh, so it actually skips this. Oh, I know why. This is because of how Python behaves. While we look at this reading right to left, and see apple tree data comes first, and then it goes through each of these things, because this line should theoretically be done. If it was written like this, it would be this, this would be the same, but they have it broken up, and it's likely just showing a little bit about how Python handles everything in its functionality. And this stuff, it starts from here, reads to the right, and because this is all in different lines, the computer starts after the equals, reads through to the right, and then gets it over to here. And once it goes through each of these, and then we get past apple tree data, it will then actually, because this is essentially initializing the first one, initializes, goes from there. It probably just misbehaved and skipped that next line because of all the weird stuff I did. And now gets to the end of the index, jumps back up to apple tree. And once I hit there, we now have our apple tree data. And then for root amount, okay. This loop will repeat once for each inner list root amount index. So this is going through here, and oh, wait a moment. Okay, that's why it was acting weird, because I didn't put it back. And now I was wondering why it was acting weird. Okay, now it should, goes back to here, fruit amount, that's the first one. Now this pulls up the next one. Fruit amount, that gets 83, and so this updates the which list it's going through, and this is when it gets assigned, and that gets it indexed and added up. And 2016, I think that was, yes, our last time through. And got to the end of the list, went back up here. realized it was at the end, and then it should print out total fruit amount 256.6 right down here. Cool. Okay. And one of the reasons I'm going through and doing this is just because I want to learn. And if I just read, I don't really learn as much. You learn by playing, you learn by doing. And could I also learn by seeing somebody else do it? Yeah, but I think just humanity learns better when we are doing. And this lets me see this. Okay. And so X is 17. Oh, yes, I remember what we're getting into here. This is showing some of the functionality of how Python handles assignments for integers, things of that nature. It's simply going to be when you go to assign something to be it will set y equal to 17. And we'll go from there. But when we then increment X up by 1 here, X will then be 18, while Y will still be 17. In the next demo that we will go into and that I'll dive into, I remember reading this, it will show how it will walk through a similar little thing of assigning integer, of assigning, creates a list and then assigns it through and goes, but you'll see that it, when you increment it up, it'll be the same because they're going to be assigning not the variable or the number over, but the actual location over. I haven't studied a lot of C++ or C, anything of that nature, but I know in C you deal with memory management, and this will be this little exercise here will give us an insight into how Python handles memory management. Whereas in C, if we were trying to do this, we'd have to actually deal with the memory management side. Python deals with it for us, but it's still neat to be able to see. And that gets us our two variables, 17 and 17. This will increment X up to 18, and then it'll print it down there. And now let's stop here and let's go to here. And now what should happen with this one, because whereas before, when we did this same kind of thing, you've got the LX of this, the LY equal to LX, and it will print up the 7 and 2. Here we'll append 5 to just LX, and then it'll go and append it to, it'll show that it'll append it into both. What I'm going to test is to see, it should work both ways. I just want to test and see, does it? And is there any difference? And then it will now print the two values. It's going to append them in, and you see it happen automatically here. And then it prints them both up. And so now I'm going to ly and let us see, does it actually happen both ways? Because this turns this equal doesn't actually copy the whole thing over. It sets a pointer to this same list. And so you have one list with two different names. And now, yep, one list, two names is what ends up happening. And it treats it both the same way. That's kind of cool. Okay, and I believe this is our last function, our last example. And let's set you up and restart you. And so that just printed there. Forget why here. Okay, so this would just be showing us minus the debugger what all's happening. I think I forgot to remove my other breakpoint, but I caught it now. X is 5. LX is okay before modifying. So LXX, this shows us before calling modify args. And then it feeds both of those, the variable in our list. Now it jumps into arguments and then okay, yeah, so they're literally showing us kind of what we're looking into here and kind of printing that, hey, this is where we're now in, and it now increments n. What is n? Okay, so n is increment is the x and adds 1 to that and then append 4 and change values of both parameters. Okay, and so they added 1 to the value of x and added 4 to the end of our list. And then it'll print that down here. And there we go. That should get us done with our program. Calling. Wait a minute. Hold on a moment. So X went back to what just happened there. X define main. Okay, so so it started off, our list started off with called up main, started off with x of equal to 5 and lx equal to -7 and -2. We then modified it, adding, we ported them into our function, added, showed that they were the same, added 1 to the x and 1 to, and appended 4 to here, and then went and jumped back out of main and printed them back up. And because of how Python handles lists, even in a function, it's still going, and even if you import it in here, it still references the same exact list in memory. But with this guy, because when the LX came through, this continuously references that, and this function doesn't return anything. And so because it doesn't return anything, and with how Python handles memory, it returned the X. The X was just copied through as it got through in the list. And so even though we changed it up here, it didn't make it back out because we didn't actually return it. But with the lists, because the list, it keeps track of where it's at, and it went from here to back through to here and realized, okay, so we're still talking about this same list, and modified there. What they referenced in the video or somewhere in here, I don't remember which one it was, that if with a list this size, who cares? But if we had a list millions of items long, trying to copy that in memory is going to be a massive memory hog. And so when they dealt with the memory management of Python and had that set up to run through automatically in the background, that made it so that the list constantly is, it doesn't get copied, it gets indexed and referenced back and forth. And even though you don't return anything, it will still go back here and actually put it out, modify your list accordingly. But with a variable or other things not like a list, I imagine the same thing would probably be done with dictionaries. Then, because dictionaries can be just as big as lists, in Python, we don't normally get to see that because it handles everything automatically. That's neat to see. And that might actually be an hour. But what am I going to be doing here next? Moment. Okay. And so my next program is, this is going to be an assignment meant to help us dig even deeper into here. And let's drop you into here, save, and now pass arguments, and let's see what I'm dealing with. And so they just want me to run through and do what I did here, and then answer a few questions off of that. But I will call this a night, and we'll probably pick up tomorrow with my next homework assignment, which is going to be the first part of a program that I haven't even looked at yet. It'll be done between today or between this week and next, but I'm going faster, so that might happen a lot quicker. Okay. Ooh, creating, oh, this looks like fun. So my next assignment, I haven't read through what we're going to be doing, but the milestone tells me that they'll give this in 2 parts, and we'll have a part that we do in the week 07 and then week 08. And let's see here. And this looks like we're going to be calculating mass and on an atomic scale, and going from there. Ooh, that's fun. I'm gonna enjoy digging into this one. But that is about all. And so I'm going to call this an evening. Have a wonderful day, and we'll see you all tomorrow.